Hi math students, it's Miss Carol here, and I am very happy to report that we are on our Unit 6 project, which is the last project for Algebra 1B, so you are almost there. And in this project, there are only 4 lessons because lesson 30 is actually just your final exam. So let's dive in to these last 4 lessons, starting with lesson 26. And this particular lesson focuses on an absolute value function, which is kind of fun. So Rainy and her friend are playing pool in a community center. If Rainy can sink the 8 ball on her last shot, she will win the game. However, she has to call which pocket she plans to make it into before making the shot. Her friend challenges her to make it into the top right pocket. The image shows the setup of the pool table and an absolute value function that can model Rainy's winning shot. Just for reference, the 8 ball is at 8 and 5, x equal 8 and y equal 5. So this is the pool table down here. The pockets are at these corners. And our absolute value function is, hopefully you know by now, they kind of look like a V. So the first question says that Rainy's plan is to hit the 8 ball so that it bounces off the side of the table at 12 and 0. The shot can be modeled by an absolute value function with the general form f of x equals a times the absolute value of x minus h, all plus k. So if we look up here, this is actually pretty cool. If we imagine this pool table to be our coordinate plane, we can see that the vertex of our absolute value function is over here at 12 and 0. And if you'll recall from previous mapping problems, our vertex is at h and k. So I can identify my h value as 12 and my k value as 0 because I'm not going up at all. Remember, our h value is our horizontal translation and our k value is our vertical translation. So vertically, I haven't moved up or down at all, but horizontally, I've moved to the right 12 units. So let's see how that applies to this particular problem. Okay. So now I know that f of x equals a times x minus 12 and then plus 0. Now, how could I solve for a? Well, one thing that I know here is that this 8 ball is at x equal 8 and y equal 5. So I could plug those values in because I do have one coordinate that's on that function. It's on the trajectory of that function. And I can then solve for that a value. So let's go ahead and do that. So I have f at 8, okay, equals 5. So if I plug this in now, I get 5 equals a times x minus, oops, sorry, I want to actually have 8 minus 12 because my x is 8. 8 minus 12, and then remember k is 0, so I don't need to do anything with that. So now I have 5 equals a times the absolute value of negative 4, which is a times 4. The absolute value of negative 4 is 4. So let's go up here. 5 equals 4a. Divide both sides by 4. And I get that 5/4 equal a. So I can either type that as 5/4 or 1.25. Okay, so that is our a value. Okay, what is the value of h? Well, we already talked about that. The value of h was 12 because I moved horizontally 12 units to the right. And the value of k, again, we already talked about that. My vertex didn't leave that y equals 0 value at all. Okay, so now we're to our last question here. Explain what would happen if Rainy moves the cue ball and makes the 8 ball bounce off the side of the table at 12 and 10 instead. Assume that the new shot is still modeled by an absolute value function, and how is this function different than the first one? Okay, so now my vertex is going to move over 12 units, but up 10. So let's quickly look at that. 10 units up means that it's gonna hit here instead of down here, okay? So intuitively, this ball, if it's gonna hit 10 units up and 12 units over, she's probably gonna have to move that cue ball down here, and she's gonna have a function, let's see if I can carefully draw this, that's gonna go like this, right? So in a sense, we're reflecting it. It's going to be exactly the opposite. It's going to be a downward facing absolute value function. So let's see what our A value would be for that. Okay, so if we still have that ball at 8 and 5, so we have 5 equals A times X. Oops, sorry, we'll make that an 8. 8 minus 12. And then now we have to add that plus 10, okay, because we changed that. So before I can really do much, I'm going to do this calculation and give us a -4 here, but I'm going to subtract 10 from both sides. Okay, so I get -5 equals A times the absolute value of -4. -5 equals 4A. Divide both sides by 4, and I get that A equals a -5/4 instead of a +5/4. Okay, so that's the difference when we moved that K value up to the other side of the pool table. So let's type that answer in. And let's see, the ball will go into the bottom. That's the other thing I kind of forgot to mention. The ball's going to go into, instead of the top right corner, the trajectory now has it going down into this bottom right corner, okay? So the ball will go down into the bottom right corner. The absolute value function will open downward instead of up because the A value is now negative. Okay, so that's all you need to type for that one. I hope this made sense. Pretty quick little initial lesson for Unit 6. I will see you back here for Lesson 27. Thank you.